Hello friends, so welcome to the second lecture of the fifth unit of this course. In the last lecture we have discussed about the change of order in the multiple integral. In this lecture I will talk about another important concept related to the multiple integral, and that is change of variable in multiple integral. So, let us understand what is change of variable. So, first take a simple example of definite integral. So, suppose I need to solve this particular integral. So, for solving this integral, what I need to do? I need to make some substitution. Substitution means I need to change the variable y. So, for doing this, what I need to do, let y cube equals to t, and from here I will get 3y square dy equals to dt. Since I am having this y square term here, so my this integral will become 1 by 3 e raised to power t dt. When y is 0, t will be 0, when y is 1, t will be 1. So, my original problem was in y, but now my variable is t, and if you look at both of these definite integrals, this is looking quite easy when compared to this one. So, we have made the change of variable from y to t by putting y cube equals to t, and then we have convert our integral in a simple form. So, we have done change of variable in definite integral also. Now, what we need? We need to extend this concept in case of multiple integrals. In multiple integral, what is change of variable? Suppose we want to integrate a function f of x y over the region R under the transformation x equals to g of u v and y equals to h of u v, the region becomes S. Like in case of definite integral, our limit changed. Here the region of integration will also change when you make the transformations or change of variables. So, region becomes S, and the integral becomes now, means our original integral was like this, a double integral over the region R f of x y dA. This will convert into, the region is now S, x will be g of u v, y will be h of u v, absolute value of the Jacobian of x y with respect to u v into du dv. So, basically what we are having? We are having R f of x y dA. This dA may be dx dy or dy dx. We are not taking the order here, means exact order, either dx dy or dy dx. So, it may be anything, whichever will be the simple one. So, now what I am doing? I am making a transformation x equals to g of u v, y equals to h of u v. So, after making these two transformations, means my original problem is in variable x and y, I am changing it into the variable u and v. So, after doing this, as I told you, region will change, and we will see by the examples how region will change. So, earlier region was R, now it will become S, f of x will become g of u v, y will become h of u v, and then this dA. dA will become absolute value of Jacobian x y with respect to u v, and then du dv. So, this is the change of variables in case of double integral. Similar concept can be extended to the triple integral. Here you have to notice one is earlier region was R, now it become S. The other thing is this dA is now Jacobian of xy with respect to uv du dv. And these two things are coming from the region. For example, suppose I am having a region, let us say initially I am having region R as an ellipse given by x square y square upon 16 equals to 1. So, this is my original region. Okay. Let us take, I make the transformation x equals to u by 2 and y equals to 2v. So, if I apply these two transformations on this region, what will happen? This region will convert x square means u square upon 4 plus y square upon 16. So, 1 by 16 into 4v square. So, v square upon 4 equals to 1, and this comes out as u square plus v square equals to 4. So, my original region was an ellipse, now it becomes a circle, and you know that integration over a circle is quite easy when compared to an ellipse, because there you can convert it into polar coordinates and you can have constant limit for r as well as for theta. The other thing which is important to notice here, what will be dA in this case. So, here first of all we need to calculate the Jacobian. So, xy upon del of uv. So, del x over del u will become 1 by 2, del x over del v is 0, then del y over del u which is 0, and del y over del v, that is 2. So, here Jacobian is coming out to be 1. So, hence dA will become simply du dv. So, if I am having a problem on this particular region, for example, if I am having an integral r which is let us say x plus y dA, now it will become s. So, r was an ellipse earlier, now this is a circle of radius 2 having center at the origin. X plus y will become u by 2 plus 2v, my Jacobian is 1. So, du dv. So, this is the change of variables which I have explained with the help of this simple example. Now, there are two regions for changing the variables. The first region is, suppose we are having the region of integration is complicated. So, can we apply some transformation so that the region will become a simple region where the integration will become easy. The other region is, if we are having complicated function here under the integration on which we have to perform integration. So, by applying the some transformations, can we change this particular function into a simple form. So, these are the two reasons behind the concept of change of variables. Now, we will take some example and I will explain. I will take an example where earlier region will be the complicated, but later on it will become simple, and the other one also. So, let us take this particular example. Here we need to evaluate x square minus xy plus y square over the region R, where R is given by the ellipse x square minus xy plus y square equals to 2. So, region under inside this ellipse and on the boundary of this ellipse, and using the transformation x equals to square root 2 into u minus square root 2 by 3 into v, and y equals to square root 2 u plus square root 2 by 3 into v. So, I am having x square minus xy plus y square over the region R, where R is given by the ellipse x square minus xy plus y square equals to 2. The transformation is which I need to apply x equals to root 2 u minus square root 2 by 3 v, and y equals to square root 2 u plus square root 2 by 3 v. So, here we are having something, some easy thing, that this is dA, the integrand and the region are having same function. So, let us see, after applying these two transformations, what will be my new function. So, earlier I am having this one. So, x square minus xy plus y square, x square will become 2 u square plus 2 by 3 v square minus 2 root 2 by 3 into u into v, then minus xy. So, minus xy will become 2 u square minus 2 by 3 v square, because a minus b into a plus b. So, a square minus b square, and finally y square. So, plus 2 u square plus 2 by 3 v square minus, and now it will become plus 2 times root 2 by 3 u into v. So, these two terms are cancel out, 2 u square minus 2 u square plus 2 u square. So, it will become, and I should write equals to 2 u square 2 by 3 v square plus 2 by 3 v square plus 2 by 3 v square. So, 6 by 3 v square. So, plus 2 v square. So, we have taken all the terms, it was equals to 2. So, this equals to 2. So, from here, after change of variables, the region becomes a circle of unit radius and having center at the origin. So, now I can write this integral. So, this will become 2 u square plus v square, because this term equals to twice u square plus twice v square. Only thing I need to calculate Jacobian. The limit will become the new region S, where S is given by the circle of unit radius. So, now let me calculate Jacobian. So, x is root 2 u minus root 2 by 3 v, and y is root 2 u plus root 2 by 3 v. So, del x y with respect to u v, del x over del u. So, del x over del u will be root 2, del x over del v, del y over del u, del y over del v. So, this will become 2 by root 3, because root 2 into root 2 will become 2 upon root 3 plus 2 by root 3 minus minus will become plus. So, 4 upon root 3. So, 4 upon root 3 absolute value of this into du dv, and S is given by this particular circle. Now, this integral can be written as 2 into 4 8 upon root 3, and if I change it into polar coordinates, because it is a circle, so means again change of variable, u equals to r cos theta, v equals to r sin theta. Okay. So, del u v over del r theta will become here r. So, it means du dv will be r dr d theta. It is a circle of unit radius, so r will go from 0 to 1 and theta will go 0 to 2 pi. U square plus v square will become r square into r dr d theta. Because it will become r cube will become r4 upon 4. So, I have adjusted 4 here, earlier it was 8, now it is 2. R4 when you substitute limit, when you will put 1 it will become 1, when 0 it will become 0. So, simply theta. So, basically it will be 4 pi over root 3. Now, take another example. So, in this example we have to evaluate this particular double integral over a region R. So, here double integral x plus y x minus y dx dy, and the region R is given in such a way that x is bounded by 1 minus y to 2 minus y, and y is between 0 to 2. So, first of all, we cannot evaluate this integral in an easy manner directly in this particular region. So, what we need to do? We need to make some transformations or change of variables. So, let us make change of variables using these two transformations, that is u equals to x plus y and v equals to x minus y. If we use these two transformations, my region R transform into R dash, which is given by v is between u minus 4 to u and u is between 1 to 2. Hence, the double integral converts into this particular double integral, that is since my x plus y is u, x minus y is v, so u into v, then I need to find out the Jacobian and then dv du. Here I am writing dv du as you know that I am having constant limits for u, so I am taking du at the end. I will evaluate it later. So when I calculate Jacobian, Jacobian is given in this way: del x over del u, del x over del v, del y over del u, del y over del v. So here del x over del u becomes 1 by 2 because x will be simply become u plus v by 2 and y will become u minus v by 2, that we are getting from these two transformations. So del u by del x, del x over del u is 1 by 2, del x over del v is 1 by 2, del y over del u is 1 by 2 and del y over del v is minus 1 by 2. So when I evaluate this particular integral, this will become 1 by 2, that is the absolute value of this, otherwise it will come out to be minus 1 by 2, and since I have to take the absolute value, so it is 1 by 2. If I substitute it here, it will become 1 by 2 double integral uv dv du. So after evaluating this particular integral, I got the value of this integral as minus 4 by 3. Now take one more example, and that is we take in spherical coordinates. So as you know that if I am having x y z coordinate system and I am having a point here x y z, okay, and I want to represent this point. So this is, let us say, my x axis, y axis and z axis. So let me take this angle as phi, this distance as rho. So what will happen? This distance will be z, this angle let us take theta. So let us take this as r. So what I will be having? X equals to rho. So here rho sin phi cos theta, then my y will become rho sin phi sin theta. So basically r is rho sin phi here. I have project this onto this line, and then z will become rho cos phi. So this transformation is called converting from Cartesian coordinates to spherical coordinates, and now my new coordinate is r, theta and phi, where phi will be between 0 to pi. Now if I convert my problem into this, that is, let us say I am having a triple integral over a three dimensional region R f x y z dx dy dz. So what dx dy dz will become in this spherical coordinates after applying these transformations. So here I need to calculate del x y z over del rho theta phi. So it will be a Jacobian, that is del x over del rho, del x over del theta, del x over del phi, del y over del rho, del y over del theta, del y over del phi, and then del z over del rho, del z over del theta, del z over del phi. So, if I simplify up by this Jacobian comes out be rho square sin phi d rho d theta d phi, and which will be equals to dx dy dz. So, this is the change of variables when you are changing your variables from Cartesian to spherical coordinates. That is the extension of polar coordinates into 3D. Similarly, in cylindrical dx dy dz will become r dr d theta dz, because their coordinates are r, theta and z. So, in this lecture what we have done, we have taken the definition of change of variables, then we have seen few examples for the reason why we do it. After that, we have seen how we can convert our triple integral which is given in Cartesian coordinate to the spherical coordinates by using the concept of change of variables. Thank you.